Good morning, good afternoon. Welcome to our virtual IoT meetup. So today we are going to talk about IoT and big data analytics. I mean, we've been covering over the last few weeks how to get your sensor data to the cloud by means of gateways, how to use Kura and the like. And today we have Brian from Splunk, who I think is going to show lots of demos and a very practical example on how to actually make sense of all this IoT data. So Brian, whenever you want to get started, it's up to you.
Yeah, thank you very much. So, and thanks to everybody for joining, and of course, thanks to Eclipse and Eclipse IoT for giving us this format. So, yeah, my name is Brian Gilmore. I'm a solution expert for industrial data and the Internet of Things at Splunk. I basically just sort of oversee the development of new products and working with customers and developing of technology partners around IoT use cases of Splunk. Just to sort of give a quick overview of Splunk, so we clearly safe harbor statement. We are a publicly traded company. I just ask that you don't use anything I say today for the nature of making investment. If you do want to keep in touch, I think for tweeting questions during this event, we'll use the hashtag virtualIoT. You can also reach me on Twitter at Brian M. Gilmore. My email address is bgilmore@splunk.com. Feel free to reach out to me directly at any point if you have questions. And then you can also reach me on LinkedIn at that link. Also, definitely recommend you go check out splunk.com/IoT. It really gives you a general overview from a much more marketing perspective or business level of Splunk for IoT. So I'm going to go a little bit more technical today. This is really designed to be more of a how-to, sort of get you through some of maybe the minor hurdles to downloading Splunk, getting it installed, and starting to get some value from the IoT. And then we'll go pretty far into how you can extend Splunk as a developer or as an end user. So Splunk's mission is to make machine data accessible, usable, and valuable to everyone. We were started by founders who worked in the data centers and were really frustrated by the fact that they had better access to data on the internet than they did in their own data centers. So they really just set out to sort of make a Google for the data center, a web-based application where they could go and ask questions of all of the data that was stored on the servers in their own environments and get answers back in the form of statistics or events or whatever it might be. And clearly that application has developed into something that's pretty special. We're really excited about all of the use cases of Splunk in IT operations, troubleshooting, cybersecurity, safety, compliance, business analytics, and also, of course, the Internet of Things. We've got a number of customers who are using Splunk to do amazing things with connected industrial equipment or consumer products, and definitely recommend you go and take a look at that splunk.com/IoT to find out information on that and take a look at some of the case studies. But like I mentioned, Splunk is really a platform for delivering machine data. And machine data is really time-stamped, human-readable data. You want to think about this as like the data that's stored in log files. What we've seen a lot of, though, is sort of a purposeful logging or a semantic logging of data now from applications. So as people want to deliver data to Splunk so that they can do the sort of ad hoc searching, the monitor and alerting, the reporting and analyzing custom dashboards, et cetera. With Splunk, they're sort of developing logging practices in their own applications. And this started, with just writing data directly to log files, and Splunk can certainly tail log files. I'll sort of show you how that works here in a minute. But we also have a number of other REST APIs, SDKs, and then a modular input framework will show you that as well. But this is not only, the IoT is not just sensor data. I mean, this is really diagnostic data. It's transactional data, if you think about connecting vending machines, the purchases that are being made, as well as all of the sensor data that's being generated by the IoT. And Splunk is a great platform for just sort of delivering all of that data and then getting value from that data, really understanding that data, asking questions of it, creating proactive alerts, KPIs, and then repurposing data that you may have used or collected for operations or cybersecurity use cases for the business to see maybe how some of that data can predict revenue streams or downtime that's going to affect customer sentiment, etc. And that's really, I believe, the promise of Splunk for the Internet of Things is to be able to give you that full-blown operations, security, and business perspective of the data that's being generated by whatever it might be. Maybe these are your industrial control systems, maybe it's your connected vehicle fleets, maybe it's some new product that you're developing. But the goal is to give you a tool that lets you get to insight from the exhaust data that's being generated by those devices very easily. And the way we do that is these are our key value propositions, but so schema on the fly. So we record in the data. I sort of think of Splunk as like a piano roll. Any data you send to Splunk is going to get put on disk in its raw format. There's literally no requirements to strip that data, to schematize it, to turn it into rows and columns. Just send it as it is, as single line or multi-line events. Only thing is that it has to be human readable and it has to be time-stamped. If you don't send it with a timestamp, we'll assign one for you. You can use that to your benefit or not. That universal indexing is really true. I mean, this could be regular log file formats, it could be JSON documents, it could be XML, it can be CSV rows, whatever you want to send to Splunk is going to get recorded again as long as it's text-based. And like I said, there is no backend RDBMS. We'll show you, I'll do a little bit of a technical walkthrough of the file structure of Splunk here in a minute, so you can see what it looks like and where the data goes and how it gets stored and things like that. And then, of course, there's no need to filter the data. So you can send all that data to Splunk, store it, and then have sort of a comprehensive record of all of the events that have been created by your environment, be it IT or IoT. And that's really important because we believe, and I think our customers have seen this, is that you never know what questions you're going to have to ask tomorrow. And if you have to make decisions in terms of what data you're going to store today, you may find out that you may have a lower capability in terms of troubleshooting or improving your mean time to resolution or whatever your sort of point of gathering this big data may be when you don't have the data stored. Because there may be some little detail in some pieces of information or events that you thought was not going to be valuable that will eventually be critical to your business. So again, no need to filter the data, just send it all to Splunk and get value from it. Splunk, being that we came from the IT world, we did develop several technology partnerships, and we've developed some technology that actually makes us more applicable, let's say limits the barriers to adoption for the IoT. Speaking specifically about the partnerships, we've got a partnership with Kepware Technology. They make an application called the Industrial Data Forwarder for Splunk, which will stream tag data from PLCs and RTUs and other industrial devices to Splunk in real time. We're technology partners with ThingWorx, so the ThingWorx platform and Splunk are interoperable via the APIs. ThingWorx can be configured to deliver data to Splunk, and it can also query Splunk and use the results of Splunk Analytics as part of logic or other processes running in the ThingWorx environments. We've got several security partners. So Red Balloon Security makes a firmware monitoring application that delivers security-relevant events to Splunk for analytics. Bayshore Networks does a very similar thing where they have an appliance that runs in an ICS SCADA environment and monitors for cyber threats to that environment. And then we have some partners who've developed top-level applications like Prelert, who does an anomaly detection application that works great on sensor data, and Predicto, who makes a preventative maintenance application that runs on Splunk and uses Splunk data to as part of its preventative maintenance algorithms. We also have developed a number of apps. So Splunk has sort of a free app model. Once you install Splunk, you can go and download apps from Splunk Base. And those apps either give you sort of top-level views into the data dashboards, or they allow you to easily ingest data from news sources. So we've built a number of apps that sort of help out in getting data in from the Internet of Things. So these are things like the REST API modular input, which lets you pull REST API endpoints and index the results. We've got an Amazon Kinesis modular input, which lets Splunk be a consumer on a Kinesis stream. Same thing for Kafka. We've got DB Connect 2 now, which is an application that lets Splunk connect up to relational databases and either query the data that's stored in the relational database, or if there are tables in that database that are time series based, you can actually index those tables into Splunk, sort of tail in each table as new rows are written to it, and analyze that data in Splunk. We do have a universal forwarder for Raspberry Pi. So a universal forwarder is a separate piece of Splunk technology that can be deployed on remote systems to collect data and forward it to a Splunk indexer. And we've got one that runs on Raspberry Pi. It's community supported, sort of use at your own risk, but it's definitely a lot of fun. I use it to monitor my fish tank at home. And then we've built modular inputs for MQTT. We actually use I think the Paho library to build that one. AMQP, JMS, and then we have an application called Stream, which is really like Wireshark on steroids. You can plug it into your environment, have it monitor a network port, and stream the raw wire data that's streaming over that network port. We've also got a modular input now for CoAP, and of course one for SNMP. So we definitely recommend you go to Splunk base once you have your Splunk installation set up and look for those. And the point of those modular inputs is then you can configure Splunk to consume that data directly from the web interface. No coding required, which is really the sort of point of practical operational intelligence and fast time to value. So how do you get started? Well, we've got simple steps to deployment. First step is download Splunk. If you are running multiple screens, or if you can just do it, go straight to www.splunk.com. I'll show you that here in 1 second. You install, you ingest the data, you search your data, and then you start building dashboards. So I'm going to actually show you exactly how that works. So let me see here. Let me stop with my screen share and let me share my browser. Oh, that's the wrong one.
Yep.
There we go.
Perfect.
Great, thanks. So I'm just going to go to Splunk.com. And the first thing you'll see at Splunk.com, or we hope one of the first things you'll see, is up in the very right-hand corner, this Free Splunk button. So when you click on that, you'll see we have sort of 3 methods to begin adoption of Splunk. And all of them are free to start. So Splunk Enterprise is probably the one I would recommend for most of the people in this audience. It'll actually download an application directly to your desktop. And you can install it locally on your laptop or in your servers or across a tier of servers if you'd like. Splunk Cloud, so Splunk Enterprise and Splunk Cloud are exactly the same application. Splunk Cloud is just a software as a service version. So if you want to set up a free online sandbox, when you spin that up, essentially it'll send you an email and it'll give you an instance to log into. And this is built through our partnership with Amazon Web Services, and Splunk Cloud has 100% uptime SLA. Definitely recommend you click the Learn More button there. And Splunk Lite is sort of an alternative version of a product to Splunk Enterprise that's really designed for small environments. Once you get to sort of commercial scale where you would need to move into a commercial license on Splunk Enterprise, if it's only 1 or 2 of you using Splunk for very simple purposes like log search and things like that, Splunk Lite is a really good option. But here again, I would just definitely recommend for development purposes or for figuring out how you can use Splunk for IoT solutions, click Splunk Enterprise. You go to the free downloads. We have Windows, Linux, Mac OS, Solaris, FreeBSD, and AIX installs. So if you install Mac, or if you download Mac OS, that's what I have. I'm going to show you exactly what that looks like. So let me change out of my web browser again. And let me go back to... So I've just downloaded the application here that, sorry, go this way. That comes with that comes from that particular download, and it's just a TGZ, so you can literally double click it to expand it, and you can run this anywhere in your environment, and you'll see it basically installs a directory structure, which has got a lot of Python in there. Some of it's compiled, some of it's not. Some of our core is C stuff, but you know, you've got a file system here that's very well documented. So docs.splunk.com is another place I definitely recommend you go once you sort of get into this and you want to find out a little bit more. Startup on the application is actually really easy. So I'm just gonna, let me do this so you guys can see my. There you go. So now you can see my actual, so I'm just gonna, you know, go to applications, virtual IoT, Splunk, bin, and then Splunk start. And this is my first time, so I'm gonna -- accept license because I've read it 1,000 times and don't want to watch the whole EULA going by. You'll see it just basically runs through, does a quick configuration, creates some configuration files, creates some new private keys, and then the important part here is you'll see that it basically tells me that my web browser is now available at port 8000. Just to look quickly at the architecture here, I think the most important thing to understand with this is that under var lib Splunk, there's now this whole file system. This is where all the data is stored in Splunk. And like I mentioned before, Splunk is an index. It's not a relational database. So there are cold DBs, and you'll see that there's actually buckets in here where the data is stored. But anyways, I'll cover that here in a minute. But to show you what this looks like on the other side now, sorry to swap around so much on the screen sharing, but let's go back down now to my web browser. So here we are again, and I'll just go to localhost 8000 because that's where it said it was going to run it. And well, that's disappointing. Well, I may have a process hung up here. I was uninstalling and installing this sort of back and forth right before I started because I was testing out the piece. I have another one running on this machine too. That might be the issue. But anyways, when you go through that process, once you start it up, you'll be hit with a web browser. And let me just log out here and show you what that looks like. So once you get to the web page, you'll basically see that you're prompted for a login. Initial login is admin change me. It'll say that right at the bottom. This one I've already configured, so I'm just gonna put in mine. And you'll be presented with a web interface for Splunk. And so that is really the installation process. Again, apologize for the glitch, but I'm not sure exactly why that didn't work. But anyways, I'm not going to obsess over it. If it doesn't work, just delete the directory and do the reinstall. So let me go back here to my slides. So that's that. So I took a look. I showed you the file system. things that are important to know about the way data is stored in Splunk. So there's a processing pipeline. I'll cover that here in a little bit, where the data is sort of brought in. And once the data is parsed into events, and then the timestamp is either recognized or assigned, it gets put into this bucketing system. And there's really three main operational buckets. One is the hot bucket, whereas the data is actually coming in from the outside world into Splunk. Those buckets are still open for write. Warm is data that's been rolled over to the warm buckets. So it's read only, but it's fairly recent. So you would want to keep that probably on your fastest disk. Of course, doesn't really matter if you're running it on a laptop, but if you're running it in a deployed environment, you would want to keep that on your faster disk. And then cold is sort of old or older data, where you can store data, that you probably wouldn't want to access. Splunk really works from the premise that the most recent data is probably the most relevant. So it always searches from now backwards when you're doing searches. And as that happens, as you get further and further back, as you move over to cold storage, your return time on your results may be a little bit slower, but in reality, that doesn't really matter because they're pretty old anyway. And depending on your storage, it could just be a difference of seconds. So not too bad. And then frozen is really an archive of data. So you can configure Splunk to take those cold buckets, and after a certain period of time, like a certain number of days or years, or after your index has reached a certain size in terms of gigabytes or terabytes, you can roll it over to a frozen archive, which is basically data that you can put anywhere. And then you can actually thaw that frozen data later if you need to load it back into Splunk for analysis. So getting data in, this really question becomes like, once you've installed Splunk either on your laptop or on your server, how do you get data in from external sources? And like I mentioned, we have MQTT modular inputs, CoAP modular inputs. I'll show you exactly how to do that. So go back to my web browser. So let's take a look at the settings here for a second. So, well, first let's look at the indexes piece. So you'll see here, in this environment, I have a lot of indexes set up. If you want to create a new index, you just do it through the web browser. So you could call this my IoT index. Again, remember, it's just a file system to store your data. So there's not really, you can have as many or as few indexes as you want. If you have some authentication requirements that you would want to store data in indexes that, where maybe only some users have access to that data, you can do so. So you can sort of use your indexes as a way to isolate data from particular groups of users. Again, the sort of capabilities of the Splunk authentication system is a bit outside of this conversation. But again, if you go to docs.splunk.com, you can read all about that. It's really powerful. Splunk integrates with LDAP and things like that. You can set the home path, the cold path, and the thawed path for your files. So if you are using multiple tiers of storage, local storage, remote storage, you can do that. And then through the web interface, you can configure the index size. So you can say, say up to 1 gigabyte, or 5 gigabytes, or multiple terabytes, depending on what you want. And then, again, read up on the documentation in terms of the sizing for the hot, warm, and cold buckets. I've always left it as auto. I've never had any issues. And once you do that, it'll create a new file in that file system, and you'll be able to deliver data to there. In terms of getting the data in themselves, if you go to apps and then find more apps in your environment, you can type in, say, MQTT and search, and this will go out and actually search the Splunk base, and then you can install the app directly from here. But I've already got it set up, so I'm going to go to Settings and Data Inputs, and you'll see that I have this MQTT modular input here, and I've connected this up to some of the B&B Electronics test servers for MQTT, and you just basically put in the topic name, put in the host, use 1883 as the default. You set your client ID if there's authentication required or anything like that. You can set your quality of service, reliable delivery, message processing, etc. And once you do that, when you go back, well, actually, one more thing I want to show you there. If you go to more settings, oh, actually, sorry, let me. If you go to more settings, you can basically direct it to a particular index. So now when we go to Splunk and say search and reporting, you'll see here we're presented with a web interface that has you know, a number of buttons to press, ways to search the data, time range pickers, etc. I'm going to hop back here, go through a little bit of what searching and exploring your data is like in Splunk, and then we will get back to this part of the demo. All right. So looking at that interface, we've got a search bar, which is really sort of our, you know, like in Google, you can type in a wildcard, you can type in search terms. I'll show you exactly how that works in the demo. You can, you know, select time range pickers. And once you run these searches, you're going to get data either off of the disk, if you're looking at historical periods of time, or you will get data that's coming in real time. And if you look down on the lower left side of this slide, you'll see some of the monitor inputs, some of the modular inputs, etc. You know, like I mentioned before, that data goes through a parsing queue, which splits it into events, does the line breaking, the timestamp identification, puts it into the indexing queue, and then the indexing queue, the real-time data gets put into that real-time buffer. Whereas if you're running searches in real time, it'll show you data as it's coming in from the outside world in real time. You can actually, you know, evaluate that data, transform that data, run analytics on that data in real time, or you can grab data off of large historical periods of time off of disk. So, you know, this offers a pretty interesting, easy to use architecture that's probably a little bit like some of the Lambda architectures that are being proposed out there. But again, it runs all in one application. So you have that real-time analytics component, you have the large volumes of historical data component, and you just do it all from this web-based application, not only from the configuration of getting the data in, but actually in interacting with that data. And I'll show you exactly how that works. I think that one important thing to know about all of this is that this scales from very, very small, like I said, on a laptop, all the way up through massive scale. So Splunk scales horizontally in that you can install Splunk on like 5 or 10 or 20 or 50 or 100 servers, and there's a configuration that lets you actually sort of team those servers up into indexing pipelines. And our largest customers are indexing hundreds of terabytes of data a day into Splunk, and they're getting real-time value from that data as it's coming in from their remote environments as well. So very powerful and very scalable and very secure as well. One of the things that we're sort of best known for is our schema on the fly. So any data that you send to Splunk that's in key value pair formats will automatically get split into keys and values. And you can sort of see, we call those auto-detected fields. And that includes key equals value, that includes key colon value. You can also do some stuff with CSV and auto detection of header rows in CSV. So there's lots of ways to send data to Splunk and not have to do any field extraction. But if you do have to do some field extraction, if there's just particular pieces of information in your files that you want to extract, we give you the capability to do that, again, right through the web interface. You can then create alerts from your data. So once you write your analytics that sort of identify the events from your data that you want to know about sort of proactively, you can create the alerts on those events. I'll show you exactly how that works. And those alerts can do a number of things. So it can just pop up in a console. It can send an SMS alert. It can send an SNMP trap. It can send an email. Or it can actually run a script. So we have this thing called scripted alerting where you can actually create a script that runs locally in your Splunk environment, and the Splunk alert will pass data to that script, and that script can do whatever you can do in that scripting language. So it becomes a really flexible way to sort of do action with Splunk analytics. And it's something that's used quite frequently by our customers, both on the IoT as well as in IT. We'll talk a little bit about dashboarding and show you exactly how to go from IoT data to dashboards, and then combining those reports, or sorry, from data to reports, and then combining those reports into dashboards. So I will flop over now and show you exactly how that works. So back in the web environment, you'll see first, we give you a little bit of summary information about your environment. So this particular environment, I've got over 1 billion events indexed. You'll see I have a couple hundred coming in per second from a whole number of sources. My oldest data is only 4 months old, believe it or not. I put 1 billion events in less than 4 months. This is really nothing. We have customers who are putting in a lot of data per day. So, you really have a capability to do some pretty large scale data analysis. And latest event is now, meaning literally like within the second, data has come in from some remote environment. So let's take a look and see what that looks like. So again, we have this we have this time range picker. You see we have a bunch of presets here for you. We can look at data in a real-time window and a relative time window. We can get a little bit more advanced in terms of the relative time. You can go a certain number of seconds, minutes, hours, days ago until now, or the beginning of the current second. You can do the same thing in real time, meaning that once you set this up, as data ages out of the window and new data comes into the window, it will be reflected in your analytics. That's really powerful, especially when you're creating real-time alerts. You could do just static date ranges. Somebody said something really bad happened with this whatever last week. You can go ahead and you can actually limit the scope of your search to that particular time range of data. You can do it down to the time as well. Or we have an actual time range language that you can learn. I'll be dead honest with you, I have never personally used this. So it may be a feature you love, but I've found that all of those other sets are pretty powerful. So let's take a look at data, say, in a 1 minute time range period. And I'm just going to do the world famous asterisk search. So when I click that, what you're going to see here is a whole lot of data coming in from a lot of different sources. You'll see we have, between 100 and 600 events per second coming into this environment. And I think you heard me earlier sort of talk about piano roll. This is one of the reasons I feel like that, because when you sit here and you watch this window in real time, you'll see the events actually roll off the edge. And literally, as those 390 events roll off that back window of this histogram, or that back edge of this histogram, that data is no longer available for this particular analytic, right? So you'll see here we've got some data in this field. So for example, this particular field is something that's coming in from one of our industrial control systems. We may have some MQTT data here. Yep, there's some MQTT data down there. But we probably don't want to be looking at everything. Now, if we're trying to do just a gross troubleshooting of some unknown issue, we may start there. But we're probably going to start with one of the fields that's automatically being extracted by Splunk. So we may say take a look at source type. So when I click on source type, you'll see here Splunk is analyzing the content of the data, and it is matching it to source types that have already been predefined. And source type has a lot to do with the field extractions and things like that. It's one of the configurations that you set up when you're pulling new data in. And like you see, we have some MQTT data here. So if I click on that, you'll see it automatically sets a filter here for source type equals BNB MQTT. And you'll notice here now that my histogram is changed. And now I'm only looking at MQTT data. So maybe I want to see like what the message is, or what the name is, or what the topic is. Maybe I only want to see data from the the sensor list. And when I click on that, you'll see it filters me down to the to just the sensor list, and now I've got this message where I can look for just VBAT, and you'll see here it actually added that VBAT up there. So you can do some pretty interesting search and exploration. I'm going to show you an example on some data we have coming in from a connected car system and sort of show you like where you can go with search and exploration. So again, I'll go down here and we'll see this source type. And I'm going to click on that and I'm going to look at EUP, which is this electric car data. And I'm going to switch out of real time here for a second just to show you field extraction. Because what you'll notice here is that the data that comes in from this eCar setup, could be very well the message payload of MQTT, but it's just a sort of semicolon delimited list of numbers. So we like to say a lot of information, or a lot of data, but not a lot of information. And you'll see everything is pretty standardly formatted. So it looks like we can probably do some pretty solid field extraction here. So I'm just going to go here and I'm going to set a defined time range of, say, the last 15 minutes. And I'm going to expand this and I'm going to go, let's extract fields here. And it's going to take me to this interactive field extractor. So say, for example, I know that this particular number right here is the battery level. I just highlight it, click on it, and I can type in battery. I'll add that extraction. And what it's going to do is it's going to go through and do some validation on all of that data. You can check all events, matches, non-matches. You can take a look at the values that have been extracted from all of the data. It looked in the first 10,000 events. You have some other choices there for that. And then once you're satisfied with the accuracy of the extraction, you can just accept it. If you wanted to actually see the regular expression it was using, you could just hit that show the regular expression, and then you can actually edit it manually if you're a regex wizard. But I'm not, so I heavily rely on this extract fields interface. The reason I show you that is A, because it's really cool, and B, because it's really powerful, and it allows you to not send a lot of overhead in your data if you're purposely sending data to Splunk where you know the format will be consistent, but also because I sort of want to explain what you're seeing over here, which is all of these fields on the left. So what I did was I went through and I just knew the format. I knew we sort of had the header row for the original CSV format, and I've created these fields. So now we have battery kilowatt level, we have crash detection, we have cruising range, we have engine speed. So you can do things like when you click on engine speed, Splunk is doing two things. First thing it's doing is it's recognizing that it's a number. And when it's a number, it will, and this is part of that whole schema at fly, or schema at read time, it will automatically present you with some options that are valuable for numbers. So like average over time, top values, events with this field, maximum over time. And it won't do that for things that are not numbers. So it's pretty interesting. You can actually sometimes have mixed fields where you may have like just a generic value field. And if it's both numbers and non-numbers, it won't present you with average over time, but then you could just do a filter where that field is not a number and suddenly it will present you with average over time. But again, those are the kind of things you'll figure out when you mess around with it. I'm just going to click that average over time and you're going to see, okay, over the last 15 minutes, the average engine speed has gone, it started pretty high and now it's low, it's at 0, which clearly means that there are no cars on the road. I think the important thing to know about this is that I didn't ask for anything specific. I literally just said for my entire eCar fleet, time chart the average engine speed. So what Splunk did was it went through, it found all of the engine speeds related to any particular vehicle, bucketed them into little windows of time, and then did an average of them all together. So you could actually split this out by, say, vehicle, and see what the different vehicles did. So you can see here that only one vehicle was on the road in the last 15 minutes, this auto 27628. All the other vehicles during that period of time were at 0 because they're parked in the garage. So it's pretty powerful in the way you can go back and forth between aggregation, and sort of detailed or granular levels. We also have a stats command, so you could do things like stats average engine speed by vehicle. And this is going to show you a very different view on the data. So it's no longer time series-ing the data. It's just taking that entire last 15-minute window, and it's giving you an average of all of the engine speed recorded for that particular vehicle over that 15-minute time. You could then go to, say, the last 24 hours and see, oh, okay, well, in the last 24 hours, the other vehicles have been on the road. It's just in the last 15 minutes that they haven't. And you'll see it's actually, as it calculates through, it's constantly updating the real-time average engine speed. So if we were to say go to a visualization here, create a column chart, move this to real-time over a 30-minute window, we could see the average vehicle speed by vehicle over this 30-minute window. And again, I'm not sure how many of these vehicles that, so several of them have been on the road over the last 30 minutes. But you can see here now a very different view. You could take a look at this as a pie chart if you wanted. But I like, this column. So we can now save this as, so what we now have is a real-time 30-minute rolling window, average vehicle speed split out by the individual vehicle, which, from that raw data format that's pretty fast to get to that type of insight. And we can now save this as a dashboard panel. So I'm just going to go and create a new dashboard panel called Virtual IoT. I'll share it out to all the other users in the app, and we'll say this is real-time engine speed. And I'll save it as a column. I'll click save, and it'll say, okay, oh, nice spelling, Brian. Well, let's edit that. Again, you can do inline editing of the dashboards as you go. And now this is a dashboard that can be shared out with anybody in your organization. You can go back, you can add new fields to it. So for example, if we go way back to our time chart, average engine speed, and let's go back and put this in a line. Let's save this as a dashboard panel. I'll put this in existing, and we've got this virtual IoT now, and this is engine speed over time by vehicle. And I'll, oop, nice, wrong click. Save, and we'll view that dashboard again, and you'll see it's right here next to it. Now you can do some pretty interesting things with this in the dashboard. For example, let's add a time range picker. So I went into edit dashboard or edit panels, sorry. I'm gonna add an input. I'm gonna add a time range picker. You've got a bunch of other sort of form fields that you can add here to deliver, because each one of these dashboard panels is just being powered by that search string that we generated earlier. So you can go in and edit this if you wanted to edit it, or you can add tokens. So you can go ahead and add a time range picker. We can set this to say today. And then I can go ahead and I can edit this search string. And instead of using that explicit, I can select that particular time range picker that I just selected. And now all of my widgets on this dashboard are driven by that one particular time range. And again, like I said, you can add a whole bunch of other form fields and tokenize the input that the user puts in to those particular form fields into the search, and then pass that through the search to the Splunk backend, where so once you get really good at sort of understanding the very modular nature of the Splunk search language, you can sorry, see funny tweets come across. Once you add this sort of, you understand the very modular nature of the Splunk SPL, which is the search processing language, you can really take advantage of having user-driven form input, which are driving dynamic searches and running analytics. But let's go back to the raw data here for a second and talk about alerting and what that means. So we're back to our source type EUP. We're looking in the last 15 minutes. Let's go back to, again, well, the last 15 minutes should work. And let's take a look at another scenario. So if we look at, say, door open, we'll see 98% of the time as this vehicle fleet is on the road, the doors are closed, which is good. You know, when the doors are closed, they're driving and they're making money. With 59 times, or 1.1% of the time, the door open was true, or 1. So I'm just going to sort of drill down on that and take a look at what we've got going on here. So you can, again, now I've just filtered down to when the doors were open. And you can see this has happened a number of times, and that makes sense. These are little short trips these vehicles are going on. But I think a logical next question for me is like, okay, well, what speed was the car going when it was stopped? Well, 0. Okay, that's good. So nothing to worry about there. But let's take a look at a little wider period of time, like today, and see if we've seen any other speeds. So you'll see here, we do have several displayed vehicle speeds. 99.3% of the time, the car is completely stopped when the door is open. That's really good news. But we have some other numbers here, which I probably want to investigate. So I'll just click on that 11. And now what I'm filtering to is times today where the door was opened and the vehicle was going 11. Let's take a look and see what vehicle. So it looks like that's restricted to just one vehicle. So if I'm just doing some basic search and investigation and troubleshooting, say I'm managing this vehicle fleet, I'd probably just go and create a work order and have somebody go address the door switch on this particular car, because it's, well, it's clearly not somebody driving around at 11 miles an hour that frequently with the door open. It's funny that we're seeing it both on the left and the right. You know, well, no, there we go. Sorry, door front left open is 1. Door front right open is, oh, sorry, those were rear. Door front left open is 1. Door front right open is 0. So we can now write that work order specifically for the front left door and have somebody fix the switch and solve that problem. But that's not really very proactive. That requires a lot of sort of manual intervention. So I'm going to go ahead here and I'm going to say, okay, forever going forward, I want to know anytime the door is open on a vehicle and the car is going faster than 5 kilometers per hour. And you'll see that this has happened a number of times now. And we probably have some additional vehicles that are in this. Yes, we now have 2 vehicles that need this work order. That's fine. I'll take care of those right now. But what I probably want to do is save this as an alert. So by saving this search as an alert and running it in real time, this is bad door switch is really what we're looking at here. I can then say, okay, per result, meaning that any time a vehicle registers this as true, do something. Or you can do when the number of results. So if you have more than 2 cars on the road that are just demonstrating this issue, you know, go ahead and take care of that. Well, the other ones are much more IT based. But so we'll just do per result. We'll say next. And we'll say run a script. And I would have written a script locally that would connect up to my work order system and can get the data, the vehicle name, the geolocation from the vehicle, etc., and put that data into a work order automatically. And once I click save, that will be always running in the background and analyzing the cars for that particular issue. And you can build a really big library of issues using these types of rules, more compound rules, etc. Cool. So we have a couple more minutes. I'm just going to walk through a couple more.
So recovering the data corresponding to a possibly to a search, is this possible to do this outside of the web UI via maybe a REST API?
Yeah, absolutely. So anything you see me doing in the web user interface is being done against the publicly accessible REST API.
Okay.
So we don't have any secret endpoints or anything like that. We use our web developers even use the same documentation. So yeah, I would definitely recommend and I'll just sort of hop right to that piece right now, and we can take a look at how we sort of go through all of this. So the developer platform, of course, you've seen we sort of have a web framework. I showed you what we would consider our simple XML dashboarding. I will show you here in a minute a demonstration of how you can do JavaScript and HTML5 dashboards with Splunk. We have SDKs for both getting data into Splunk, getting data out of Splunk, and doing all the administrative functions for Java, JavaScript, Python, Ruby, C#, PHP. And then we have sort of, again, outside the scope of this conversation, data models, some search extensibility where you can write custom, those search commands you saw me running like time chart and stats and average. And you can actually build your own using Python. There's also an app, if you go to Splunk Base and search for the R project app, there's an app that lets you spin up an instance of R right next to Splunk and take advantage of the R statistical processing language from right within that that search processing language, which would let you use R inline in your dashboards or your alerts or whatever you needed to do. And then we have those modular inputs, which we'll talk about. The web framework, I think, is really important. dev.splunk.com, if you're a developer, is really where you want to go. That's probably, it is the best resource for developing on Splunk. You can even request a developer license. Like if you just want to really mess around with Splunk, build some integrations, maybe you want to custom build a new user interface or custom build a modular input for Splunk, you can request a developer license of Splunk, which is free and will run for 6 months. So if you are a developer, I definitely recommend you take a look at that. You can also download all the documentation on building custom interfaces with JavaScript and HTML5, maybe using D3 or whatever. And I will show you sort of what that looks like. Let's go back here to you. So if you go to dev.splunk.com, you'll see there's a whole bunch of get started documentation. There's information on the web framework, which shows you exactly how to reuse or use things like D3 or 3JS, different libraries for visualizations. We've got of course, all of our documentation on our REST APIs. You can just download the Splunk SDKs right here. There's some additional developer tools for developing apps or logging for .NET and Java. And then, of course, you can request your developer license directly from there. But I want to show you sort of based on what we did with that eCars app there, what you could build out with, say, the web framework. So we've created an application on this same underlying data using these same types of searches as you see here, using the web framework, just HTML5 and JavaScript. So you'll see what happens here when I load this app, which is a Splunk app. Again, an app is sort of a file system that contains the visualizations, the custom searches, et cetera, for a particular domain. This one's for managing that eCar fleet. You'll see a very different view. So again, we have that same time range picker. If you want to look at today, we can see just the cars that were on the road today. And you can see the number of trips that were taken over time. These are driven by those same types of searches that we just generated directly through the search interface, but are displayed a little bit different. Histograms for each one of these searches, and this is all extensible through that JavaScript library. One of the really neat things is that you can create sort of KPI indicators. So what we said is for each vehicle in this fleet, the customer is going to want to know for the particular period of time today what the average battery percentage was. So we can see, okay, 75%, 72%. Maybe you wanted to drill down to a vehicle that had a low percentage. And when you click on a particular vehicle here, you'll see we've built this separate interface where you can actually see a playback of the vehicle on the map. And again, when I sort of talked about the fact that the index is a recording of the data, it allows you to table that data out using that time chart command that I showed you. And then using that table, you can iterate with JavaScript or your favorite processing language for the web. You can actually iterate through those rows and do some very impressive playbacks. And that's what you're seeing here. So this is the car as it's sort of going through its full day today. And you're seeing, its speed, its RPM, the battery. You can see when the doors open and close. We don't have, for this particular demonstration, the heart rate data, but if the drivers were wearing, Fitbits or some other web accessible heart rate data, we could use Splunk to call out, get that data, and then mash it up, just assign that heart rate to that particular car, and then it would automatically become available in this visualization. So, I mean, again, this is really what you can do with Splunk, and there's nothing stopping you from doing this. I mean, if you're anybody can really download Splunk, start getting data in, and start writing some very basic Splunk searches in a day. I've seen people within a week starting to develop custom modular inputs for their own data sources, be it some automation and control system or some third-party data source like a web service or something like that. And then, once if you're already good with JavaScript or you're a web developer, you can immediately start developing dashboards like this once you understand how the searches run and how the searches power the user interface. And again, that dev.splunk.com documentation is really the best way to go.
Very cool. We have a bunch of questions. If you have more questions, you still have time to tweet them using the hashtag #VirtualIoT or drop them on the meetup page. So yeah, we had a question about the REST APIs, which we answered. In most of your demo, I think you were using MQTT messages where the payload was probably a JSON format. What if the MQTT messages the messages that are fed into Splunk are actually in some sort of binary format or using Google protocol buffers and stuff like that? Is there a way to still analyze this data and query against this data?
Yes, so the modular input framework allows for a custom message handler. And that custom message handler can be in Python or Java. So you can pretty much do whatever you want to do with it. If you want to do sort of, I would say, large-scale binary data decoding of the data that you're delivering to Splunk, two things I would recommend. One, you could do the decoding somewhere else and just send the human-readable data to Splunk. Or you may want to take a look at an app called Protocol Data Inputs, which is a framework like the modular input, that allows you to do some pretty advanced in-stream processing of the data using things like Clojure or Python or a lot of the programming languages. So you can actually, as the events are being processed, you could be doing binary decoding and sort of decapsulation and turning that data into key value pairs so it would be better prepared for the Splunk index.
Okay. Yeah, we have another question which maybe will be easier to answer offline, or at least in the comments on the meetup event. Question from Amit. Splunk is pretty much similar to BERT, Actuate, or now OpenText iHub. Is there any specific difference between these two? Maybe in just a few words, if you can answer that.
Well, yeah. So I think the back end of Splunk, in terms of its ability to ingest large volumes of structured, semi-structured, and unstructured data, is a little bit different. So we're sort of like, I know a lot of those platforms tend to sit on top of other data stores. So we are sort of end-to-end data collection, secure transportation over the network, parsing of that data into events, timestamping of that data or extraction of timestamps. Then we have that unstructured index, which is definitely different than most of those companies' approach. So we can have that powerful search and investigation. We have the schema on the fly, which as you sort of get a little bit deeper into Splunk, you'll understand like what it means to be able to evaluate, to create new fields on the fly, to do lookups, to external lookup tables, and pull that data in to enrich your data in real time. And then once you get up to the top level, to the visualizations, I mean, there's a lot of tools out there that can dashboard. In fact, Splunk actually can be sort of faced with tools like Tableau or Click or any of those BI or visualization tools that can connect with data over ODBC. So yeah, on the visualization side, very similar, but we have sort of that whole power of the back end, as well as that entire developer framework, which people really seem to enjoy.
I'm just checking in, but I think we are running out of questions and of time. The webinar is recorded as always, so if there are further questions, feel free to let us know in the YouTube comments or on the meetup page directly, and I'll make sure to forward them to Brian. So thanks so much for the presentation, Brian. I think we will be back in 2 weeks' time for a presentation on how using JavaScript for prototyping hardware, not only programming IoT devices, but actually prototyping what eventually is going to be your hardware platform. So yeah, you may want to check that out. It's already online on the meetup.com event page. So thanks again, Brian.
Thank you very much, and thanks again to Eclipse and Eclipse IoT for the format. Really enjoyed it. Thanks again.
Thanks for joining us. Bye-bye.